Alright, welcome YouTube. It's been a little while since I posted a video. I thought I'd do one on a quick install of an SC8C computer. I'm going to use this to control 8 turnouts and some signaling on my layout here. So I picked that up and go ahead and install that. Now, just as a disclaimer, I've never installed one of these before. I have no clue. But we'll just go ahead and start out with the COM cable. I had this made from a local hobby store real quick. I don't have the tools to make my own, but it was just a few bucks. I have an LT one. It's a little plug that you use to actually test those cables. If you get 4 green lights, that's a good hit. Trust it. So I'm using a paddle bit here to make a bunch of holes in this little flip board I made right here, to allow all the wires to pass through to go under the layout, and then when I don't want this board my way, I can just flip it back under the table and hide it. Of course, in future videos you'll see it's not in this location no more. At the time of filming, I actually end up moving this thing because I put it on the side of my layout that's very near water mains. Terrible place to keep electronics, so I moved this to the other side of the layout ultimately. But the installation is nevertheless none the same, and I didn't refilm it when I moved it. So anyways, it comes with a pin connector, a test mask with the LEDs, and get the tamale itself, the SC8C board. Like I said, I bought this mostly to control turnouts, but it will control like 32 or up to I think 64 signal heads along your layout, which definitely adds a lot of realism, especially if you're into like a lot of operations and such. And of course you got the instruction sheet. I'm definitely going to need that. Like I said, I've never installed this before, so it is going to come in very handy. So I'm going to use this pencil. I'm going to scribe around the little 4 holes that are in this particular circuit board. I'll just go ahead and mark that spot where I want to put it. Move that out of the way. Go ahead and take a drill, and we're going to go ahead and pre-drill these spots so the screws will go in a little easier. A piece of hollow tube, a pair of side cutters, and the screws. I'm going to use this hollow piece of tube and cut that into short little sections to actually float the board off of the mounting surface I'm using to insulate it, and then some on the top to act as washers between the screws and the board itself. Okay, I'm going to put this communications cable up through here and hook it into the back of the SC8C. There's 2 ports on here. It doesn't matter which one you put it on. All Digitrax stuff has 2 ports on each device, and they're just made to piggyback each other. Other end's obviously connected to the command station, as we're going to use this to tell this board what to do. Move this stuff out of the way. We're going to have to hook a power supply up to this. So I have this Digitrax power supply. You can change the voltage on it. It's got plenty of adapters. It'll be perfect for this project, as we have to solder our power supply to the board, as there's not just a place where you just plug into it. The power is actually fed through the blue terminal strip that's on the front of the board. And this is the adapter, one of the adapters for it. It's pretty much a universal type power supply. So I'm going to go ahead and make a piece of power lead for it. I like to use red and black wires for anything power on my layout. If it's tracks or the boards, anything, it's always red and black wires. Just easy to keep it simple. Any other colors is just any other thing. Right, now I got that power lead done. Now's a good time to go ahead and get our test mass hooked up. It's already connected to its own little harness. Do a couple little bends here. It's a little fidgety. Get that placed so the lights are facing up so I can see it operating when I give it a test. Alrighty there, that should do. And let's get our soldering iron heated up because we're going to do a little bit of soldering here. I like to tin all the ends of everything first. This makes soldering it much easier, much more professional. Go get those set in there. And now that the wires have been soldered up to my connector, go ahead and finish the job over here by tightening down the wire so it doesn't jump off the board like my screwdriver just did with that screw there. Alright, interesting things to watch on YouTube. Struggling with a screw. I will make it work. Pound on it with the back of that screwdriver. Okay, it's tight enough. Good enough. Doesn't matter. We're moving in the future anyways, so we don't care. Alright, let's go ahead and pull up the power supply, plug it in. Boom. We now have power to this board. Little LEDs have begun to shine. We've now brought in a little life to this. Let's see if we can change those LEDs, make them different colors and do different things by using the command station. Yeah, and we're certain if we can. There's going to be a lot of these on my layout eventually, and they're all going to be controlled through called a JMRI computer software program when I figure out how to use that. So that'll be a future video very many moons down the road. Alright, now I'm hooking up the wires here. We're going to go ahead and go to the Tortise motor. The Tortise is just a slow motion machine that actually moves the little switch points on the track back and forth so your train can switch between tracks. I want all these to be able to be controlled by my computer or the command station as opposed to having to reach over the layout and go switch them manually. Okay. So here's this Tortise slow motion machine that I'm going to be using. These things are great. I picked them up off a bargain table for $10 each. These things are awesome. I'm going to go ahead and attach the wires from the SC8C to this, and we're going to go ahead and do a quick little bench test before I commit to installing it to the layout. Once again, I like to tin all the surfaces real quick. Go ahead and attach it. Let's do a test here. We'll go over to the command station, hit our switch button. Switch 1 is what it is on this, and then we'll hit the open close button. Let's go ahead and have a look, see if that's actually doing anything. Sweet, that's what we want to see. Remote control of a switch. Alright, there's a couple more things I'm going to have to do this Tortise motor because you never know what you might want to do in the future, and these things are capable of a little more than just having 2 wires hooked up to them. Alright. So I'm going to go ahead and add a few more wires onto this tortoise motor because I'm going to install this thing in a very unconventional and maybe even controversial way in the modeling world. Normally you put these under your table going upright with the wire going through a finely drilled hole to operate the motor. My layout is very thick in styrofoam, so we're going to go ahead and lay this thing sideways. And I call this kind of like the coffin mounting method of it because you're going to lay it sideways instead of up and down. But I'm going to go ahead and put some extra wires on this because when this thing's installed, I'm not going to want to touch it ever again. So thank God these are super reliable because I'm never going to want to replace it. Just put all of these wires on here. That way every function of this tortoise will be available to me long after I change my mind on something without having to dig it up or remove it. Here I'm just completing the last bit of the wiring for the tortoise motor so I can go over here and install it. This is the turnout. We're going to put that. It's going to be the first one the SC8C will be controlling on my layout. Just going to take off the manual thing. Go and measure this. And initially I did try to put this vertical instead of horizontally, but it was just a lot easier to put it vertically. As the layout is using hollow core doors, those are about an inch or so thick, and then I'm running about another inch, or in this location actually 2 inches worth of styrofoam. So best way to do it I thought would be just to put it in sideways. But like all good modelers, I tried to put it in the right way. It just wasn't going to work out for this situation. I've already glued all this stuff together and it's kind of in the middle of the layout. So creativity is something you have to be prepared for if you're going to be a modeler. A little bit more fidgeting here. Now I'm going to go ahead and go through that hollow core door, pop that out. Push that all in there. A little bit of work. Nice little hole all the way through. And I did put it in and like, no, that's not going to work. It's just not going to work. Yeah, fit in there great and all that, but the way the wire was, that tortoise actually has to be under the switch, which would require a lot of damage to hard work I already did to my track. There's just no way I was going to rip that switch out. The new modeler, I'd already done it twice, and I certainly wasn't going to do it a third time. I'm fidgeting with it. I'm doing everything I could think to work. I actually edited a lot of this video out, so you guys didn't have to see so much of the suffering and pain of me trying to figure out how to get this to work correctly. I came up with the idea, well, let's just put it in there sideways. You have to make that hole a little bit bigger. Put notches here, stuff it in there. I do want it to be tight. Once it's in place, it's gonna have to be wiggle free. Alright, we've got that pushed in there pretty good. And as far as to do the wire, instead of lacking a fulcrum, is what I did is take the wire and I bent it into the shape of a V. That way when it pushes to the left, it springs and keeps tension on the closed side, and then when it comes back the other way, it stretches and puts tension on the open side, keeping nice tight points at the point. This worked out quite well. Here you can see I'm doing a few tests to it, moving it back and forth. Pretty happy with the operation. I'm going to stuff in a couple shims of styrofoam here to make this very, very, very tight, as we don't want it to change its relationship inside there. Like I said, I call this the coffin method because we're laying this sucker in the ground and that's where it's going to stay. So I'm going to take a piece of styrene here. I'm sanding on one side so there's something for the glue to stick to. I'm going to use this piece of styrene and we're going to put a top over this and cap this. I put a little slit at the top of it to clear the wire right at where the point lever is. just about there. Go ahead and glue this down. We need some weight to hold this thing down. Of course, a little block of wood in my vape's not going to work. This is going to take a lot longer than I want, so I'm going to put glue and scenic materials on there. Let's walk away for a while, let that dry. When we come back, it's for the most part dry. We just get a good look at what we've done. Alrighty. Well, this video is starting to run just a wee bit long, and I gotta save some materials for the next video that I'd like to post for y'all. So here we'll leave you with a night scene of my running trains. In an upcoming video, we're probably going to do a tour of the Anderson Hog Valley Railroad. We're going to install a Wi-Fi controller to operate trains with a telephone. There will be some videos coming up on JMRI, and of course, obviously, more wonderful time-lapse builds of these wonderful little wood kit buildings I like building. Maybe some plastic ones too. But thanks for watching. Absolutely, please come back and subscribe, and I hope to see you all guys on future videos. Thank you.